everyone. Today we are going to learn about how to factor quadratic equations and expressions whenever a is not equal to 1. But before we get started, I would like you to please go ahead and factor each of these expressions. I want you to factor x squared minus 17x plus 72, x squared minus 4x minus 60, and 3x squared minus 300. Now for this last one right here, you might want to factor out a greatest common factor of 3 before you get started with factoring. So go ahead and pause the video, factor each expression, and then restart the video and we'll see how well you did. All right, let's go ahead and check our answers. So for x squared minus 17x plus 72, what we want to do is break this down into two parentheses, splitting apart the x squared into an x and an x. Then we want to ask ourselves, what two numbers multiply together to equal 72, but together add to equal negative 17? And the numbers that I think of off the top of my head are 8 and 9. So I'm going to make both of them negative because negative 8 plus negative 9 is equal to negative 17. Yet a negative 8 times a negative 9 is a positive 72. So I have an x minus 8 and x minus 9 as my answers. The next one, I'm going to split this apart into two parentheses, splitting apart the x squared into an x and an x, and now I'm going to analyze the number 60 and ask myself, what two numbers multiply together to equal negative 60, but together add to equal negative 4? So thinking about the number 60, 10 and 6 always comes to my brain first. So I'm going to write down 10 and 6, and I know that if I make 10 negative, negative 10 plus 6 equals negative 4, and negative 10 times negative 10 times 6 is negative 60. So my parentheses will have an x minus 10 and an x plus 6. And finally, we have 3x squared minus 300. Both of these two terms have in common a 3. So I'm going to factor out a 3 or divide out a 3. And I'm left with x squared minus 100. Now, x squared minus 100 is special. This is a dot situation, a difference of two squares. So I don't want a lot of thinking that goes along with this. The square root of x squared is x, so that's going to go into the first position. The square root of 100 is 10, so that's going to go into the second position. Plus and a minus. That's using the rule, we call it a day. The 3 stays on the outside, it goes along for the ride, we don't ignore it. We don't use it as we're continuing, we just leave it on the outside. Now, notice that for all of these problems, I did not identify what the root or x-intercept or the zeros were because I wasn't asked. I wasn't solving an equation, and for some reason, students like to take factoring to another level, and I just want to make sure I emphasize we are not solving any equation here. We're simply factoring, and factoring means you leave your answer and using parentheses in factored form. So now that we're talking about factoring, all of those were pretty easy. Our a value was 1 for all of them. We used a cute little x to come up with our answers. But now we're going to change the game a little bit by making our a value no longer 1. So that's our learning objective for today. I want you to be able to say that I can factor quadratic expressions when a is not 1. So when a is not 1, using a variety of methods. So there's quite a few methods and approaches for factoring. The main ones that we're going to use in this class is guess and check and another method called Xbox. There does exist X to grouping as well, or using the distributive property backwards. I'm open to multiple ways. The approach that I strongly encourage you and urge you to use is the guess and check method, and we're going to talk about that in a moment. But after today's lesson, if you find that you are genuinely struggling with factoring, I need you to email me or stay after school immediately. Factoring is not going away in this class and will be on every single test for the rest of the year. So I need you to make sure that you pay attention to this lesson especially. So that's our first I can statement. Our next I can statement, I can factor out the greatest common factor in order to factor expressions completely. So some of these problems might have a GCF, and I need you to know how to identify a value or a term that all of the numbers have in common. But so going on from there, we have two methods that we're going to be focusing on in this lesson for factoring a polynomial when a is not equal to 1. So one method is called guess and check. And this method, believe it or not, is the preferred method. It's the method that's actually the easiest to work with. It's also the one that has less steps. A little bit more thinking is involved, but it is the preferred method, especially if you're going on to pre-calc or algebra 3 with trig next year. So here we go. We're going to factor using guess and check, and that's exactly what we're going to do. We're going to be working, solving this problem by guessing our answer and checking to see if it's right. So looking at 3x squared plus 8x plus 4. When we started these problems in our last lesson, we started off by splitting apart the x squared into an x and an x. Now it has the number 3 in front of it. So you have to think of the only ways for you to multiply numbers to get to the number 3. And the only way that you can multiply two numbers to get to the number 3 is if you multiply 3 times 1. So I'm going to multiply 3 times 1. So this is technically 3x and a 1x. That's a 1x right there. And now I'm going to work with the number 4. My goal is for it to work with the terms of 4 and to come up with some kind of 8. I need to get the number 8 by working with all of my factors. So I need to focus on the term of 4. So whenever you are multiplying, whenever you multiply two binomials, our goal is to come up with our OI, whenever we FOIL, our OI to come up with the number 8. So I know that just sounded super confusing. Let me clarify. Whenever we FOIL, we know that the first term times the first term equals the first term, and the last term times the last term equals the last term. But the O and the I, when you multiply the outer terms times the inner terms, we end up with two terms in the center that somehow combine to equal our B term, our middle term. So what I mean by that is this. We know that our first term should end up being 3x and an x. But our last term, we could be working with 1 and 4 or 2 and 2. We don't know which one's going to work in this case. So that's what we're going to check. We're going to guess which combination is going to work and to check to see which one produces the number 8. So I'm going to start with 1 and 4, and I'm going to start by putting 1 and 4 into the last position. So I know that 3x times x is 3x squared, and 1 times 4 is 4. But I need to come up with an 8. So I'm going to check the outers times the inners. So 3x times 4 is 12x, and 1 times x is 1x. Is there any way for me to get an 8 from 12 and 1? No. So that tells me that this combination is not going to work. So I'm going to instead rewrite this problem, and I'm going to flip-flop the 1 and the 4. So I'm going to put 4 right here and 1 right here this time. And I'm going to multiply 3 times 1 and I get 3. And 4 times 1x and I get 4. 3 plus 4 is 7. 3 minus 4 is -1, +1, depending on how you approach it. And unfortunately, this combination doesn't work. So now I'm going to try 3x and x. And because 1 and 4 didn't work in either combination, I'm now on to 2 and 2. And I'm going to try that combination. Once again, 3 times x is 3x squared, and 2 times 2 is 4. So now I'm going to check my OI. So I have 3x times 2 that equals 6x, and 2 times x is 2x. 6 plus 2 does indeed equal 8. So I think that I found my right combination of numbers. Now I need to figure out the signs. Fortunately, both of these signs are plus, so I'm going to make both of them plus. And now I'm going to FOIL. So in order to check our answers, we're going to use the FOIL method to FOIL it out. So 3x times x is certainly 3x squared, and 3x times 2 is plus 6x, and 2 times x is plus 2x, and 2 times 2 is equal to 4. So now I'm going to combine my like terms in the center, and I end up with 3x squared plus 8x plus 4, which is exactly what we wanted our answer to be in. It's 3x squared plus 8x plus 4. That's what we started with. That's what we ended with. Here's our factorization. 3x plus 2 and x plus 2. Now please know that whenever you're solving these problems, you could end up with an x plus 2 times a 3x plus 2. It doesn't matter which one you use, both mean the same thing. So they mean the same thing. And that's because order does not matter whenever you multiply. So if you multiply 4 times 5, it equals 5 times 4. Whenever you multiply two binomials together, as long as the components are consistent and the same in your parentheses, you know you did it correctly. So this is called the guess and check method. I really like this method. There's a little bit of thinking that's involved, but if you were able to see that the combination was 2, 2 right away, that was the one that was going to work, awesome. You don't have to go through and check every single factorization or every single factorization that we have. You can just go with the one that you want to try first. And I strongly recommend that you go with the factorization that we use most often. Whenever we think of that number, that's what comes to our head first, kind of a thing. All right, the other method is called X box, X and FOIL box. And what we want to do is factor 4x squared plus 16x plus 15. So what we're going to do first is we're going to fill in the x that we have here on the side using the information from the quadratic equation in standard form. So what we're going to do is we're going to multiply a times c together. So in this case, our a value is 4, our b value is 16, and our c value is 15. And notice at the top on this x, we have a and c. So let me zoom up just a little bit. We have an a and a c. What this means is a times c. So we're going to multiply our a value times our c value. I like to call the top the addic, and we're going to figure out what two numbers multiply together to equal our addic. 4 times 15 in this case is 60. Our b value is 16, and that's going to go down here, and I call that the basement. And we need to figure out what two numbers multiply together to equal 60, but together add to equal 16. So that's a 16 right here, 1, 6. And notice on the sides we have dx and fx. So once we figure out what numbers will work with our x, we're going to attach x's to it. So what I mean by that is this. 60, whenever I think of 60, I always think of 10 and 6. And I think 10 and 6 is going to work in this case. 10 times 6 is equal to 60, and 10 plus 6 equals 16. Awesome. So what this means, this 10 and 6, is that we've just expanded our 16. So like whenever we FOIL, we have 4 terms that we come up with, and we combine the 2 in the middle to come up with our middle term. So technically at this point, I have 4x squared plus 6x plus 10x plus 15. That's what I have so far. So that's where the x's come from. The d and the f are just there as variables, implying that we're working with numbers. So in my working backwards to come up with our factored form, this is what we have so far. Now some people might have learned how to do factoring by grouping, and if that's the case, you're more than welcome to use factoring by grouping, but I'm going to go ahead and show you the box. So in the box, I have the first term is 4x squared, and it goes into the first box. Our last term is 15, and it goes into the last box. So this is supposed to be inner and last. So our outer inner, that's where 6x and 10x are going to go. They're going to go along the diamond, or along the diagonal, excuse me. So if you had 6x down here and a 10x up here, that's totally fine. It does not matter the order in which your middle terms would go, or the sides of your x would go. What does matter is that the first term is in the first box and the last term is in the last box. So now what we want to do is we want to factor the greatest common factor from each row and each column, remembering to factor out any leading negatives. So what I'm going to do is I'm going to look for what 4x squared and 10x have in common. Now both of these two terms have in common a 2, since both of them are even numbers. So I'm going to factor out a 2. And since both of these terms have at least one x, I'm going to factor out an x. So 2x is the greatest common factor between 4x squared and 10x. Next, I'm going to identify the greatest common factor of 6x and 15. Both of these two terms do not have an x, but are both divisible by 3. So I'm going to put a 3 on the outside. Now, that's one approach. You can work with the greatest common factor. Another approach is to use multiplication, just like this. So I'm going to ask myself, what times 2x equals 4x squared? And that's going to be a 2x. And I'm going to verify, is 2x times 2x 4x squared? Why, yes, it is. And is 3 times 2x equal to 6x? Why, yes, it is. So awesome. This 2x is exactly what we need it to be. Next, we have 2x times what number equals 10x? And that's going to be the number 5. So I'm going to ask myself, is 2x times 5 equal to 10x? Why, yes, it is. And now I'm going to check my last term. Is 5 times 3 equal to 15? Yes. Awesome. So now my factored form is what we have on the outside. So my parentheses are going to be 2x plus 5 and 2x plus 3. Since both the 3 and the 5 are positive, we just put the plus signs in front. Or you could also write this as 2x plus 3 times 2x plus 5. Both expressions mean the exact same thing because the parentheses are the exact same in both expressions. The only thing that changes is their order. Means the same exact thing. So both answers are correct. Let's go ahead and flip the page. All right, so this inner last, that was an error on our notes. So now I want to emphasize that guess and check is the preferred method. So whenever you are solving these problems, I strongly recommend that you try guess and check first before resorting to the Xbox method. The Xbox method takes a lot more time and is a lot more work than what you realize. So I'm going to do letter A for you guys using both methods. And then I want you to do letter B and letter C on your own by pausing the video and trying them. So I'm going to draw a little line just to show separation between my problems. And I'm going to start off with guess and check. So I'm going to break my parentheses down into 2 parentheses, splitting apart the 3x squared into a 3x and an x, since that's the only way for me to come up with 3x squared. Next, I'm going to look at the number 8, and my goal is to get a negative 10. So I need to look at my factors of 8. And the first thing that comes to my mind whenever I think of 8 is 4 and 2. So I'm not going to mess around with 1 and 8 quite yet. I'm just going to work with the numbers that always come to my head first. So 4 and 2. All right. So my goal is to get a negative 10. So I'm going to work with the OI, and I'm going to put, I'll put 4 right here and a 2 right here. So 3 times 2 is 6, and 4 times x is 10, and I want to get a negative 10, so I have to be kind of strategic about that. Maybe that'll work. So what I did here is I had 3x times 2 equals 6, and 4 times x equals 4x. So 6 plus 4 is 10, but I want a negative 10. So what if this was negative 6 and a negative 4? Negative 6 plus negative 4 does indeed equal negative 10. Oh my goodness, I just figured it out right away. There's my factorization. 3x minus 4 and x minus 2. Now let me verify my first term. 3x times x is 3x squared, and negative 4 times negative 2 is negative 8. Okay, I figured it out. Awesome. Great. Done. That's how fast and how easy guess and check can be. So there we go. But the other approach is to do Xbox. So let's go ahead and look at Xbox. What would that appear to be? So I'm going to multiply my addic. 3 times 8 is 24. And I have to figure out two numbers that multiply together to equal 24, but together add to equal negative 10. All right, so thinking off the top of my head, two numbers that when multiplied together equal negative 4, but together add to equal, equal 24, but together add to equal negative 10. All right, whenever I think of 24, I know that 2 and 12, 2 plus, okay, I think, well, I want a positive 24. So I know that 2 minus 12 equals negative 10, but 2 times negative 12 equals negative 24. So I don't think that that's going to work in this case. So I think that I'm going to try 3 and 8, but that's going to give me an 11, so that's not going to work. Maybe 4 and 6. Well, 4 plus 6 is 10, and negative 4 plus negative 6 is negative 10, and negative 4 times negative 6 equals positive 24. I think this is actually going to work. So I'm going to write negative 4 and negative 6. Negative 4 times negative 6 is positive 24, and negative 4 plus negative 6 is negative 10. Awesome. So now I'm going to write down my first term, which is 3x squared, and my last term, which is 8, and my middles is going to be negative 4x and negative 6x. Okay. So now I'm going to identify my greatest common factor. So 3x squared and 6x, well, they're both divisible by 3, so I'm going to put a 3 up here. And they both have an x, so I'm going to write 3x. And I'm going to ask myself, what times 3x equals 3x squared? And that's an x. So now I'm going to ask myself, what times x equals negative 4x? And that's negative 4. And what times 3x equals negative 6x, and that's a negative 2. So let me verify. Negative 2 times negative 4 is positive 8. Negative 4 times x is negative 4x. Negative 2 times 3x is negative 6x. Awesome. I have my factorization, and that is 3x minus 4 times x minus 2, and I still ended up with what I originally got with guess and check. Do you guys see how much more work that is? It's a lot of work, a lot of extra thinking that you don't necessarily have to do if you can just master guess and check. Now, obviously both approaches, like I said, I will accept, but I strongly recommend that you really try the guess and check method, because I want you to show as little work on these problems as possible. It's not often that your math teacher says that, but I'm telling you that that's what my goal is for you, to show as little work as possible for these problems. So go ahead and do letter B on your own. Go ahead and pause the video and try them. And when you are finished with trying them, go ahead and restart the video. All right, let's go ahead and see how well you did. So for letter B, if I were to do this using the guess and check method, this one's a little bit trickier when it comes to guess and check, because we have two things that we need to guess for 6 and as well as for 15. So it's a little bit trickier, but whenever I think of the number 15, I always think of the numbers 3 and 5. So I'm going to start off by putting 3 and 5 automatically into that position. And I'm going to write an x and an x, and I'm going to work with the factors of 6, like 2 and 3. So I'm going to try 2 and 3 first. So I'll put 2 right here and 3 right here, just to try it. So I'm going to go 2 times 5 is 10. My goal in this case is to get a 1 somehow. I need to get a 1 because that's my B value. So 2 times 3 is 6. I'm sorry, 2 times 5 is 10, and 3 times 3 is 9, and I know that 10 minus 9 equals 1. Okay, so I just said 10 minus 9 is equal to 1. So I need 10 to be positive. So that would mean 2 times 5. I would need that to be a positive 5. Minus 9, so that I would need that 3 right here to be negative. Let me see if that works. 2 times 5 is 10. 10 minus 9 is 1. Oh my gosh, I just figured it out. Done, just like that. And it was just guessing, going with factors that we work with most often. If I had put 3 right here and 2 right here, it would not have worked, but I would have flip-flopped some things around to come up with my answer. And I think that that's the better approach. So you should have ended up with 2x minus 3 and 3x plus 5 as your answer. If you need to see the Xbox method when I see you next time in class, please make sure that you let me know, and I'll go through that when I see you in class. Let's go ahead and look at letter C. For letter C, we have 3x squared plus 5x minus 12, and I'm going to break this down into 2 parentheses. The only way for me to get a 3x squared is to write that as 3x and x. So now I'm going to look at the factors of 12. And whenever I think of the number 12, the first thing that comes to my head is 3 and 4, and then 2 and 6, and then 1 and 12. So that's the order in which I'm going to check the terms. So I'm going to start off by putting 4 right here and a 3 right here so that my 3's are in different parentheses. My goal is to get a 5 somehow. I have to get a 5. So I'm going to multiply 3 times 3 and I get 9. And I'm going to multiply 4 and x and I get 4x. And I know that 9 minus 4 is equal to 5. Awesome. Okay, so I need a positive 9. So I did 3x times 3 to get 9. So I need that to be positive, which means that I need my 4 to be negative. So now I'm going to check again. 3x times 3 is a positive 9, and negative 4 times x is minus 4, and I do end up with a 5. And I'm going to check my last term. Is negative 4 times 3 negative 12? It is. Awesome, I just came up with my answer. Done, just like that. For this problem, if you need to see the Xbox method, let me know when I see you next time in class. Let's go ahead and move on. So for example number 2, we have ourselves special products, and sometimes you will be able to factor an expression using those special products. Remember that those special products are dots or PST, and I strongly recommend that you keep your eyes peeled for opportunities to use those patterns, because those patterns will save you so much time in your process. So let's go ahead and look at example letter A. In example letter A, we have 2 terms, 81x squared minus 25. These 2 terms are both perfect square numbers. There's only 2 of them. They're being subtracted. This is called a difference of 2 squares. Difference, we're subtracting our 2 squares. So now I'm going to take the square root of our first term. The square root of 81 is 9, so I have 9x and a 9x. The square root of 25 is 5. So I have a 5 and a 5, and my pattern says I'm going to have a plus and a minus. And that's because a positive number times a negative number equals a negative number, and that is simply our answer. For letter B, if you ever see something as crazy as this, where your first term and your last term are perfect square numbers, that's your clue that this is a perfect square trinomial. 9 times out of 10, if you see something as complicated as multiplying 49 times 64 and figuring out 2 numbers that multiply together to equal that crazy number, but together add to equal 112, this is the time where you need to really look at what your patterns are. So here's what the pattern's going to be. Our answer will be a parentheses squared. So I'm going to take the square root of 49z squared, and that's going to be 7z. I'm going to take the square root of 64. That's 8. Our middle term is a plus, so my answer will have a plus, and that is simply your answer. There's nothing more for you to do. For letter C, we also have 9r squared minus 66r plus 121. If you can imagine multiplying 9 times 121 and using that Xbox method, it'll be incredibly complicated. Don't do that to yourself. Recognize that this is a PST situation. So therefore, this is going to be a parentheses squared. That's what our structure, our final structure will look like. Where I'm going to take the square root of 9r squared, that's 3r, and the square root of 121, that's 11. The sign of my middle term is a minus, so I'm going to put a minus in the middle, and there's my answer. We call it a day, that is it. We have our last little section, and then we are finished for this section, for this unit. I'm sorry, for this section and for this lesson. All right, so our next part is factoring out monomials. So factoring out monomials is very fancy for factoring out the greatest common factor. So factor out the greatest common factor first. We also call that the GCF. So the greatest common factor first, and that's just like the problem that we did in our warm-up today, where we had to factor 3 out from the very beginning. And voila, look at letter A. Letter A has 3x squared minus 300, and both of these terms have in common a 3, and our leftovers is x squared minus 100. So what I did is I divided each term by the number 3. The 3 stays on the outside of the parentheses. We ignore it, but we don't forget it. It's a part of our final answer in order for us to go back to what we started with. Now, for this problem, we have ourselves a dots, a difference of 2 squares. So we split apart, we take the square root of x squared, and we end up with an x and an x. Then we take the square root of 100, that's 10 and 10. And then we're going to make our signs a plus and a minus, because a positive times a negative equals a negative number. And that's your answer. Let's go ahead and look at letter B, and then I want you to try letter C and letter D on your own. So for letter B, we have 8m squared plus 28m minus 120. Now, all of these terms certainly have in common a 2 because they're all even. But I want you to try even bigger. We want to find the greatest common factor. And in this case, 8 is divisible by 4, 28 is divisible by 4, and 120 is also divisible by 4. Now, unfortunately, 8 can't go into 28 evenly, so we know that 4 is going to be our greatest common factor. So our leftovers is going to be 2m squared plus 7m minus 30. So what I did is I took all of these terms and divided it by the number 4, and that's how I got the inside of my parentheses. Now, 4 is part of our final answer. We ignore it, but we don't forget it. Now I'm just going to focus on factoring the inside of the parentheses. So like I said, I'm ignoring the number 4, but it's still part of our final answer. So now I'm going to look at 2m squared, and I'm going to break that apart into 2m and an m, since that's the only way for me to get a 2m squared. And now I'm going to look at the number 30. Now, whenever I think of 30, the first thing that comes to my mind is 5 and 6. The next thing that comes to my mind is 3 and 10, and then finally 2 and 15. So that's the order in which I'm going to try different problems. So I'm going to put a 5 right here and a 6 right here. Okay, my goal is to somehow get a 7. That's what my goal is. That's my middle number. I have to get that number somehow. So I'm going to multiply 2 times 6, and I get 12. And 5 times 1, that's going to give me a 5. 12 and 5. I know that 12 minus 5 equals 7. Awesome. Okay, so I need a positive 12. So that means that 6 has to have a plus sign in front of it, and 5 has to have a minus sign in front of it. So I'm going to verify that again. 2 times 6 is 12, and 12 minus 5 is 7. Awesome. Cool. There's my factorization, and I'm done. So like I said to you guys before, I want you to go ahead and try letter C and D on your own. I want you to pause the video, try them on your own, and then restart the video, and we'll see how well you do. All right, let's go ahead and look at letter C and see how well you did. Hopefully for this problem, you were able to see that negative 7y was your greatest common factor. So in this type of problem, you want your leading term to be positive. So if your term is ever negative, factor out a negative number. Always factor out a negative number to make sure your leading term is positive. So in this case, my leading term is negative 7y squared. I need my leading term to be positive. So I'm going to factor out a negative 7y. And what I'll be left with is a positive y plus 9. And that is your answer fully factored. This is not considered a difference of two squares simply because it's not a minus. Difference means minus. And y is not being squared. So this is simply your factorization. There is nothing further for you to do. Next, we have negative 25m squared plus 60m minus 35. Once again, we need our leading term to be positive. So since all of these terms are divisible by 5, I'm going to factor out a negative 5. It's a lot easier to factor when your leading term is positive than when your leading term is negative, and we want to make this as easy as possible. So I'm going to write this as 5m squared, and then 60 divided by negative 5 is negative 12, so that's going to be minus 12m, and negative 35 divided by negative 5 is positive 7. You can always tell if you factored correctly by multiplying that number back into the parentheses to see if you end up getting with what you started with. Now, I'm going to keep negative 5 on the outside, and I'm going to break down my 5m squared minus 12m plus 7 into two parentheses. The 5m squared, there's only one way to factor that, and that is a 5m and an m. So that's automatic. And 7, whenever I think of the number 7, there's only one way to factor a 7. That's 1 and 7. So I'm just going to try a few different things. I'm going to put 1 right here and 7 right here. And my goal in this case is not 60. My goal is negative 12. That's my new middle number. My goal is negative 12. So 5 times 7 is 35, and 35 times 1, that's going to give me either a 36 or a 34. So I know that I did not do that right. So that combination did not work. So let's try the other way. I'm going to write 5m and m, and this time I'm going to put 7 with 5, and I'm going to put 1 with the other m. Okay, so we have 5 times 1 is 5, and 7 times m, that's going to be 7. 5 plus 7 I know is 12. So I know 5 plus 7 equals 12, but I want a negative 12. So let's try negative 5 minus 7 equals negative 12. And that's actually what I'm looking for. So I need to turn 5 into a negative 5. So that means I'm going to have to make 1 a negative. And I need to make 7 a negative as well. Let me see if that works. 5 times negative 1 is negative 5, and negative 7 times 1 is negative 7, and negative 5 minus 7 is indeed negative 12. So let me check my last term. My last term is plus 7, so this is a plus 7. Negative 7 times negative 1 is indeed equal to 7, so there's my answer. Awesome. There's my factorization. And that is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I will see you next time.